All right, halfway through page 7. James needs a loan of $7,000 for 6 years. He is offered the following options for plans. Plan A, 10% per year. So that would be our interest rate, and it compounds semi-annually. Or 8.1% per year, compounded quarterly. Which plan will make him pay the least? Oh, always good reminder to read the question, right? James needs a loan of $7,000 for 6 years. So yeah, he definitely wants to find which one is going to have to use, is going to charge him the least interest, because he doesn't want to pay back more than he has to. And this is not TVM solver. So we're going to be using our compound interest equation. So for plan A, we have PV is 7,000, and then we have to get our I, which is R 0.1 for 10%. Semi-annually is twice per year, so we divide by 2, 0.05. And then we have to get N, the number of compounding periods, which is T, the number of years, times the number of compounding periods per year. Semi-annually again is 2. So our N is going to be 12, and then it's just our formula for compound interest. FV is equal to PV times 1 plus I to the N. So we have 7,000. 1 plus I, I'm just going to add it together. 1 plus 0.05 is 1.05 to the power of 12. So we have 7,000 times 1.05 to the power of 12. And that gives me $12,570.99. Which means, it's not asking this explicitly, but the interest, he started with 7,000, so the interest must have been $5,570.99. So how much he ended with, or ended up paying, minus how much he borrowed, would be the interest. Plan B. Same idea. So PV is still 7,000. I is now going to be 0.081, 8.1%, and then divided by 4 because it's quarterly. 0.081 divided by 4 is 0.02025. The number of periods, compounding periods, is going to be 6 years multiplied by 4 periods per year, 24. FV is equal to PV, which is 7,000, times the interest, basically like rate of growth, essentially. So 1.02025 to the power of 24, because future value is exponential, right? And that gets us 7,000 times 1.02025 to the power of 24 is $11,325.48, which means the amount of interest for this one was $4,325.48. So that is the better deal, which we would say in a therefore statement. All right. We have a $6,000 investment invested over 5 years at a rate of 4.5% compounded weekly. Same thing as the previous question. So FV is equal to PV times 1 plus I to the N. So I, our rate, is 0.045. Then it's weekly, so that's over 52. Wow, this is going to be a terrible number. 5 divided by 52 gives me 0.000. Let's do 4 numbers, 8, 6, 5, 4. Wonderful. And N is going to be 5 years, and it happens every week. So that's going to be, what, 260? So we plug everything in. 6,000 is 1.000864 to the power of 260. Gives me a total of $7,513.24. All right, here we've got some statistics. Mean, median, and mode. So mean, remember, is just the average. We just add them all up and divide by the number of numbers. So I'm going to pause while I do that, and then we'll keep going. All right, so adding them all up, I get a total of 505, and there's 19 numbers. We just do the division, 505 divided by 19, and we'll go 1 decimal place, 26.6 will be our mean. Median, you can write them all in order, or you can just find the middle one by chopping off the top and bottom. So this is the middle sequentially. Rewriting them in order can be a good strategy because it helps with mode as well, but I'm feeling like I'm not going to today. So lowest is 6, highest is 41. Now you keep taking off 1 on each end, and there's 19, so I know I'll just have a single number left in the middle. I won't have to do the average of it or anything. 8 is the next lowest, along with 39. And we've got 10 with 37, 11 also with 37, 15 also with 37, 17 with 36, 23 and 34. Next lowest is 29, highest is 32, lowest is 30, highest is 32. All that's left is 31. So the median is 31. Now if there was an even number, there'd be 2 in the middle, and I'd have to take their average. Finally, mode. Which one shows up the most? Well, we've got 37 once, twice, and 3 times. I don't think anything else comes close. There's 2 32s, and that's about it. So that's another reason, like, putting them in order can make it easier to find mode. But in this case, there's no problem. The mode is 37. Remember, with mode, if there's 1, that's the mode. If there's 2 or 3, they're all the mode. If there's none that show up more than once, or if there's more than 3 that all show up the same number of times for the most, then there is no mode. Next, company salaries are shown below in thousands of dollars. Calculate. That is not how that should look, right? This should be X bar, which is the mean. To 1 decimal place, is the mean a good measure of center in this case? Why or why not? Well, let's calculate it first, and then we'll talk about it. X bar, well, we add them all up and divide by the number of them. So 35 plus 34 plus 56 plus 300 plus 37 plus 46 plus 55 plus 60 plus 65 plus 60. So I get 748, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So our average is 74.8. So is that a good measure of center for this data? Well, let's put them in order too. Maybe that might help illustrate things. So we had 34, 35, 37, 46, 55, 56, 60, 60, 65, and then 300. So it's saying our middle is way down here. Well, that doesn't really seem like the middle of our numbers, right? Like, let's just pretend that one's not there for now. We basically have numbers between 35 and 65. So we'd be looking 55-ish would make sense to be sort of the middle of those numbers. Now, mean is not going to be perfectly in the middle of like the range like it happened to be in this case, but you would expect it to be at least inside there. Being outside, being greater than every single number but one, mean is not a good measure of center. So that is something you could describe it that way. The easiest way to say is measure, is it a good measure? X bar is not a good measure of center. Well, why? Because if you remember in class, 300 is a massive outlier. An outlier is just anything that's just way, way different than all the other data. And you'll see here, it takes our mean, which would probably be somewhere in the 55 range, and drags it way over, past like almost all of the data we have except the outlier. And this is a case where median would be better, because if it was median, we'd take off the high and low, and high and low, and high and low, and high and low, and we'd end up with a median of, whoops, just 55.5, the average of those two numbers. And the median is really good at just getting rid of that outlier and not letting it affect the data so much, whereas the mean is very, very sensitive to outliers. Perfect. Let's find the range and standard deviation for this data set. So I'm going to fill out my table, and then we'll get going from there. All right, that's probably better than me writing everything in by hand. It should be much easier to read. So what are the columns here? The first one is our one moment. All right. First one is just our x values, or sometimes we call them xi. So x1, x2, x3, x4, just the values we had from the question. Then we have our x values minus the mean that we discovered before, just up above. And then here we take those values from that second column and we square them. Because if we use these ones, they're going to add up to 0. So we need to square them so we get something else. And then first up, we actually have to calculate the variance before we can calculate the standard deviation. And the standard deviation is just the average, the mean of all of these numbers here, divided by the number of numbers. So we add all that up and we get 57,501.6 over 10, because there were 10 numbers, which is going to be 5,750.16. And then the standard deviation is just going to be the square root of that number, square root of 5,750.16. And in this case, oops, not a typo on my calculator here, will get us 75.8, which is really, really big for standard deviation when most of our numbers are below 70. Again, a big problem because that outlier exists. Now the question also wanted the range, and I probably could have written this better, which is just the biggest value minus the smallest. So the biggest was 300, and the smallest value was 34. So the range is 266. Now, I'm going to actually switch the sides that I have these on. And we'll talk about that in just a second. Oops. So it's important to remember, I see people get this wrong a lot, the range is the range of the actual values, the xi values. So it's this column, not the range of anything else we've done. Whereas the variance, these columns are just to help us calculate the variance. So once we have it, we have to add up this column, the final column, to get our numerator. Okay? So range is the actual values. Variance, those columns are part of the calculation. And then, ooh, that was a long page. That was 2 pages. I guess something got bumped down here. So we'll do a little probability, and then we'll move on for the next time. All right, because we needed another row. Let's tidy this up a little bit, and I'll be back. Sorry about that. Hard to use all the stuff on your desk at one point. I was kind of reaching for the keyboard there. All right, so we have a 4-sided die. What's a 4-sided or a 6-sided die have? It has the one number 1, one number 2, one number 3, one number 4, one number 5, and one number 6. So we know how a die is set up, so we know what the probabilities should be. So this is an example of theoretical probability. I'm not just doing an experiment. I'm not rolling it a bunch of times to see what happens. I actually know what the outcomes are. So the probability of rolling a 4, how many ways can I roll a 4? Well, there's just the one. So the probability of rolling a 4 is the number of ways I get what I want, which is 1, divided by the total number of outcomes, which is 6. And it could ask you to put that as a decimal, which would be 0.167, or as a percent, 16.7%. So to get to a decimal, you just do the top divided by the bottom, and then to get to a percent, you multiply by 100. All there is to it. So it's probability of not getting a 2. So that means a success would be a 1, or a 3, or a 4, or a 5, or a 6. So I get what I want 5 ways out of the 6 options. And that would be 83.3%. A 3 or a 5. Well, there's 2 ways to get that out of the 6. And we know we can reduce fractions. I can divide the top and bottom by 2 to get 1 in 3, or 33.3%. And finally, an odd number. Well, that would be 1 or 3 or 5. So there's 3 ways to succeed out of 6. I can simplify that fraction by dividing the numerator and denominator by 3 to get a half, which is 50%. All right, we'll call that one here, and then I'll be back with number 5.